We will then move on to the Vital project. I will first start by describing the process of implementing learning analytics in our universities. Niels Martin will then present the data analysis instruments that they have used to analyze the data. And together with the project partners, we will present some research results from the project. Right. So Vital is a European Erasmus Plus project which was funded under the Strategic Partnerships program. It is a project about learning analytics in higher education. We have implemented learning analytics in different courses, collecting, measuring and analyzing learner data of students in 4 different types of online language and math courses. These are distance and blended learning courses from 3 European universities. The aims of the project were to measure the real uses of students when they use the online resources we put at their disposal. Do they actually use the resources as it was meant in the course design? Because this information would allow us to test the course design hypothesis. Another aim was to see if we could identify different learning patterns in the data, to identify possible user profiles, different types of uses of the platform or the online learning resources, and to relate this learning behavior to study success. And an important aim of the project was to feed back these new insights to the students and instructors themselves through the use of dashboards, visualizations of the data. Our approach to learning analytics is really bottom-up, meaning that we start from the courses. So we have selected courses and we really start from the context of those courses. We implemented a descriptive explorative research design. So we did not have the intention to predict study success starting from the learner data. This was not the main aim of the project. So an important thing is that interpretation of the data needs to be done in the context of the courses under analysis. This is really crucial because if you look at the data and you don't know what the course is about or how it was designed, then the interpretation will always be, partly false. So it's also important to state that learning activities in the online learning environment, or the LMS, are only a part of the learning process. So we cannot derive everything that's happening in learning from these online learning data. Very important actionable feedback. So the data that we collect and the interpretation that we can give needs to leave room for pedagogical intervention. Can the instructor intervene and make changes so that students still adapt their behavior to improve learning? An important issue, of course, in each learning analytics project, as Niels Kleter also indicated, is the privacy of the student and the ethical treatment of their data. So from the start of the project, we dealt with issues as student consent. Students are aware of their data being tracked and also of the kind of use that's being made of their data. We have processed the data in an anonymous way, and the interpretation is always done by the instructor of the course. Students have access to the data later on, in the course of the semester, through their access to the dashboards. So we have 4 quite different courses, but we wanted to implement a common approach to learning analytics. So, as I hope you can see from the table, we have the 4 courses have different blends. We have different modalities from blended to full distance courses. And the Hasselt University course is a flipped classroom design where students spend more time learning in self-study and preparing for classes than the actual session class time. All of the courses are organized in weeks, 9 to 12 or 13 weeks, and they all work towards a class or towards assessment deadlines. The online learning environment, in 2 cases, the UCLAN courses, they were in the Blackboard learning management system, and the other 2 courses were in an online learning environment that was developed in-house by Hasselt and UVA. So the kind of data that we collected were engagement data, which used to students make of the resources, which functionalities do they use, which activity types are used most, which is the order of use in their navigation. Time spent is also an indicator, and weekly planning, so how do students plan their learning activities. And for the Hasselt University and UVA courses, we also have performance data in the form of, well, they are very exercise practicing oriented, so there's a lot of exercise material, and that's why we have scores, performance data, or assessment scores as well for UVA. So this is the behavioral data. We have linked metadata necessary for the interpretation of the data. There's course metadata, for example, which course contents are supposed to be processed in which week. There are class schedules when the students have the classes or the assessment deadlines. And there are, of course, student metadata from the university student information system, metadata such as the secondary education program from the students, and, of course, the final exam grade for the course. So quickly to the process of implementing learning and analytics before I give the floor to Niels. We have implemented learning analytics in 4 steps. So a first step is selecting and preparing the data, the metadata. So these data and the indicators are specific for each course. So we designed a pedagogical and technical tracking design, which contains a summary course design description, allowing us to compare the courses and their designs. A selection of indicators that we found most interesting, fitting the research questions that were most important to us. Looking at which course and student metadata are available and are useful. And we have used a common tracking vocabulary, and this is a bit more technical. We have used the Experience API specification, which is a new standard for learning analytics. And Ben Betts, who is here today, will speak a bit more about the XAPI specification. But briefly, it has allowed us to use a common language talking about behavioral data. So for the 4 courses, we have used the same vocabulary describing the learning activities of students. So, for example, when a student has attempted an interaction, this is an exercise, then the verb is attempted and the activity type is interaction. When a student has posted a comment, then the verb is posted and the activity type in the XAPI specification is discussion. So this uniform way of talking about, well, describing the learning activities and logging the learning activities makes it possible to compare, of course. Step 2 is logging the data to a learning record store, a student data warehouse. So the data of the students of the 4 courses were logged, sent to a central warehouse. And this was HD2 Labs Learning Locker, learning record store. Step 3 is analyzing the data according to the priorities that were set by the course teams in advance. So we have looked at resource use, navigational paths of students, time investment, spread of activities over the semester, and performance data, and finally correlations with exam scores. Step 4 is sharing the data, reporting the data through the use of dashboards, which I will show after on. Okay, so Niels will then tell us a bit more about the data analysis and the instruments that they have used. Move on to the Vital project. I will first start by describing the process of implementing learning analytics in our universities. Niels Martin will then present the data analysis instruments that they have used to analyze the data. And together with the project partners, we will present some research results from the project.
Okay, so the data table that Anouk showed with all the events, the XAPI statements, basically represent events. So they basically represent the process that a student follows when interacting with the online learning environment. And the analysis of such events and processes belongs to the process mining domain. So process mining involves the analysis and the extraction of insights from process-related data. So this table here is a very simplified example of how such a data file that's used as an input for a process mining analysis can look like. Each line in the table represents something that happened on the learning environment. For example, the first line represented the student with a particular ID logged in to the learning environment at 5:45. The second line represents that same student started access and exercise a bit later. So using these kind of event logs as an input, we performed some analyses. So first, in the pilot phase, we did a rather exploratory overview. We applied some process mining techniques on pilot data that was made available by each of the partners. I'm not going into detail on those results, but the results of the pilot study are already available on a report on the project website. For the main analysis, so the pilot phase was rather exploratory. For the main analysis, we first discussed with each of the partners which are the priorities, which insights you want to gather from the data. And based on this needs analysis, we decided to focus our main analysis on 3 topics, the 3 topics that are listed here. The first topic are the identification of student interaction patterns. They represent the order of use of learning activities. So in which order are students using learning activities? Are they going to a theory page first and then going to exercise, the other way around? Which patterns are the most frequent? In a minute, Andre will show a visualization of how those patterns can be visualized using process mining techniques. The second topic are the development of learning analytics metrics. So these metrics are used to quantify student behavior. We started from the pedagogical and technical design of each of the courses, and we developed some metrics. For example, an example of a metric can be the number of sessions that a student took, the number of learning activities of a particular type, for example, number of exercises that he executed. It can be the positioning of student activity with respect to the classes that are scheduled for a particular course. So those kind of metrics were developed, and all of them were implemented in R, which is, I don't know if everyone is familiar with R. R is a programming language which has extensive functionalities in terms of data manipulation and data analysis. And finally, the third topic that we analyzed is we performed the cluster analysis. So the goal of the cluster analysis is the creation of student profiles. So students behave in a particular way, but what we're interested in, are there certain groups of students that we can distinguish which behave similarly on the online learning environment? So to quantify the behavior of students, we use the learning analytics metrics developed in the second point. We use them as input for the cluster analysis. So more from a technical point of view, the cluster analysis is executed in 3 steps. So we started with developing what is called a cluster table. That's basically just a table where each row represents a student and each column represents the value for a particular learning analytics metrics. In the second step, we determined the appropriate number of clusters. We use a dedicated R package, which is especially developed to determine the number of clusters that is that is present in a particular data set. So then we used a number of clusters. We created the cluster analysis using classical k-means clustering. And it's important to know that we created the clusters based on the behavior of students. And then afterwards, we profiled or described the clusters that we find based on their exam score, the program that they follow, to see whether the students would experience different behavior on the platform are also differ in terms of, for example, the program that they follow and the score they get for the course. The metadata was used for the profiling. So we created groups based on behavior, and then we described those groups in terms of what they studied in secondary education, the score they obtained, and so on. So the metadata was used for the profiling afterwards.
And are there notebooks of these R's?
So before passing the floor to the instructors to show some of the results that we obtained for a particular course, I want to give some recommendations that we as a data analysis team would like to make with respect to the use of process mining on learners' data. So what we observed, and that's also a logical thing, is that students have a lot of flexibility to work on the online learning environment. So there was a lot of variation with respect to the behavior that we saw for students. That's why it's important for a data analysis team to have flexibility on the level of aggregation in which we can look at the data. We can study the path that the student takes through the course, but it's also interesting to look, for example, to a specific learning session or the way in which they interact with a particular exercise. So this has to be taken into account during the logging phase, because you have to provide, for example, an identifier for a particular learning sessions. You should add, for example, combine all the statements that are related to the execution of a particular exercise by a particular student using an activity instance identifier. So during the logging, you should provide data analysis team with enough flexibility to study student behavior at different levels of aggregation. A second recommendation is, of course, that it's possible to do richer analysis when you have multiple statuses that are recorded for a particular exercise, for example. Consider if you also have information on the intermediate execution of an exercise. For example, you know when a student submitted a partial answer to the question. It's, of course, possible to do richer analyses than when you only know when a student opened an exercise and when he closed it. So much richer analyses are possible. And finally, it's also interesting, as Anouk mentioned, we had a lot of metadata about the course, for example, course schedules, the timing of classes. Such information is also very useful to enrich the analysis because it can be used to basically find explanations or particular patterns that you observed in the data. For example, a very interesting thing that we found is that we really see a peak in student activity on the learning environment right before there's a class scheduled. So the kinds of patterns, you can only discover them when you also know the timing of sessions, for example, or face-to-face sessions, for example. This was very briefly the data analysis instruments that we use, but more details are available in our report on the project website. And now I pass the floor to André to discuss one of the results for EVA.
Yes, the big question is, of course, what does this mean for a teacher, an average teacher who doesn't want to read a statistics report but wants to be informed about how did the course go, what did the students do, did they do what I intended them to do? So to be informed about the course design that you had and see what actually happens. And there are various visualizations provided from the data. You will see more, but here we'll look at just one, a simple one, although it looks already scary. But this one is more on, did the students, what type of activities they were involved in what order? And this is for, you have several of these pictures depending on what kind of course. This is a course in mathematics, a mathematics part in a big course for biomedical students and biology students. And the mathematics part is almost completely online, so we can gather the data of what they are doing and what kind of activities they follow, in what order. And they have theory pages, they have exercises to practice, and they have assessments, weekly assessments, a lot of them. And what you see here in this picture, and I'm not going to in all the details, but it shows you many of them go directly to the assessments. That might look strange, but in this type of course, when it's the freshman course for biology and biomedical students, we brush up the knowledge they should have already have from mathematics, and we invite them actually, if you think that you can do the assessment, do it. And that's what happens here. So a lot of sessions start with an assessment. And maybe they just do the assessments and stop. You also see here big arrows. That doesn't mean that they repeat the assessment, but they have more than one assessment to do per week. And so they continue to the next one. Also, a large part looks at theory pages. Theory pages going to exercises and back maybe to the assessments. So these pictures, they give you an idea of what are students really doing. Does that match with what you expected actually or wanted your students to do? And it gives you the data show you what they really did. And so you can decide, is this going as I want, or do I want to redesign my course or tell some. This is an analysis done after the course, so that for next time you can adapt to it. Yep.
Can I ask something? Can I understand the way you represented this data? Is the thickness of the lines represent correlates with the number of students?
These are 200 students. The numbers that you see is here, like there were 9,500 assessments done by these 200 students, and in the number of sessions. And the arrows, the thickness of the arrows, shows a bit in a quick view where the major transitions are happening.
Well, in that case, you said, the way I understood is that you were worried, you were noticing that a large number of students started with the assessment.
Yeah, that's here.
To me, that graph says that your overwhelming majority of students started with the theory, and they progressed to
No, then I've been a bit imprecise because I couldn't discuss all the details. But there are two types of arrows here. You see the dotted ones that show you they enter a session, a computer session. What are they going to do? So the majority, you see this number is bigger than the ones who go to the exercises. And then within these sessions, they might do just the assignments, but they also could switch to a theory page if they started with an assessment. And you see that all, the ones who are in this theory exercise, and that is also the course design reflection. So it's, as a teacher, I can interpret this picture where you are still having questions and doubts, but for me this picture makes sense because the course consists of a theory page, some practice sessions, a theory page, some practice sessions, that's a section. So you can see what happens, but you can see also that some of the students you expect they will do an assessment, have a problem with a question, go and look at an exercise which is similar, and go back. So the behaviors of the students are extracted from these data and visualized in here a big summarization of how is the whole class doing. It's not a particular student, but the whole class, how they work through your materials.
So I just wanted to talk a little bit about the UCLAN data. First of all, I should start with a comment perhaps about Blackboard. We use Blackboard to collect our data, and we had a little bit of trouble from a technical point of view. It's quite difficult to collect data using Blackboard on the technical level, and also the degree of detail was perhaps not as rich as we would have liked. So that's just a little aside about that. However, we did manage to get data, which is very, very good. And so here I'm just going to mention a few conclusions and possible interpretations. Of course, these are just possibilities, and we would need to go continue the research to know whether or not we can really consider them to be valid. But anyway, first of all, speaking about peaks in activity, we noticed that there were peaks in activity and in engagement with the learning platform when there was going to be assessment information made available to the students, or grades or feedback. So that we could say that our students are rather assessment-oriented and feedback-oriented, which correlates with what we know from how they behave in class and feedback from the lecturers. In terms of success, we could say that successful students seem to engage more with the learning platform, so do more sessions, but the session duration seems to be shorter for successful students. Perhaps this means that successful ones also tend to be more familiar with the technology. We're not sure exactly. This leads to my next point, which is that considering that shorter session duration is linked to successful students, short time on task could be due to the fact that students are downloading materials rather than using them online on the platform, again, depending on how familiar they are with how to use that. We also noticed that some parts of the course were underused. For example, some self-assessment quizzes. Is this because students are not familiar with how to use those? So maybe, and also the lecturers, because as we've heard a few times today, the involvement of the lecturer in motivating students to use the online platform seems to be quite important, and that's what we found too at UCLAN with our data. So perhaps some of the underused parts, that could be due to the fact that students were not familiar with those parts of the course, and also that lecturers didn't motivate students or didn't encourage students about those parts of the course. And finally, we noticed that the levels of activity between different groups differ quite a lot. So different groups were taught by different lecturers. When I talked to the lecturers, we found that some had actually encouraged students to go to the platform more. So perhaps again, the differences between groups could be put down to how much the lecturer influenced the students in using the learning platform.
Okay, thank you, Victoria. I will now give some results of the cluster analysis for the EU Hasselt data. In the cluster analysis, 2 clusters were identified, one having 142 students and another one, a smaller group of 100. So the smaller group had more active behavior on, for example, the number of sessions, which is how often they log in and start a session online. So you can see a median value of almost 39 as compared to almost 21 for the larger but less active group. The same difference, even a bigger difference for the number of time the learning activity exercise. So the number of exercises they did was a lot higher than for the more active group, the cluster 2. And the same thing appeared for the theory pages, which is another activity types in the Hasselt University course of French. So in total, we for the cluster analysis included 19 behavioral variables. Then these 2 clusters were profiled. They were compared to profiling variables such as the oral exam score. So we could see that cluster 2, the smaller group, but the more active group also scored significantly higher than the less active group, a mean of almost 11 as compared to 8 for the less active group, meaning that more activity was correlated with better exam results. Another profiling variable was study program. So our course of Economic and Business French is for 5 different study programs. And here you can see the 5 study programs, and we can see that the less active group, the red one, is more represented in first bachelor applied economics students and also in the commercial sciences second bachelor study program. And the opposite is true for the other programs, the smaller groups of business engineering students and commercial engineering students. So in those study programs, there are more active students. And this is a finding that, reflected the intuition of the lecturers who had the impression that stronger students are in the study programs of business engineering and commercial engineering. Other profiling variables were used, but this is just to give you an example. So I will close the section on the main research findings with some conclusions for the 3 universities. Some commonalities in the findings. The analysis of the data allowed us, Hasselt University and UVA to validate the online course design. So we could see from the data, the planning, when the students plan their data, which contents did they select when, that they did prepare for the classes in advance, as we hoped, for the classes or before the assessment deadlines. So these types of visualizations were made that show that most students work online one day before, one day before or the day itself, the day of the classes. So finding was for Hasselt University and UCLan that more online engagement correlated with higher exam grades. And this was not we could not observe this for the UVA course because it's a different kind of course where students with very different basic skills of maths need to get to the same level to continue in their university program. So that means that stronger students will need less activities online, will need less practicing to pass than the weaker students. Time spent was not always an indicator of efficient learning, in the sense that, for example, for the Hasselt University data, we looked at students when they not only accessed exercise, but also completed actively the exercises, so really spent time on this and actively made these exercises, that the time spent was shorter actually for successful students, the average time spent on one activity. And for the UCLAN data, we saw that successful students had often less long sessions, less time spent for one session. So we could identify specific activities that were performed significantly more by successful students, and some of the metrics of which I showed some, they correlated with study success, such as the number of sessions. Negatively correlated was cramming for deadlines for the UVA course. If you see that students are really preparing just one day or even the evening before the deadline, that this correlates negatively with study success. Of course, these are correlations. It's not causation that we can evidence here, but this is the kind of feedback, the kind of actionable feedback that we have used to develop our dashboards as input for recommendations to students. So telling them what successful students do can motivate them to be more active or to perform specific activities more online.